Okay, so your I can statement today is determine whether figures are similar, and a new vocabulary word is similarity transformation. We're not going to do the critique and explain, but let's take a look at example 1. Okay, so if line M is represented by the equation x equals -3, what is the graph of the image where we have, this should be a reflection, so that should be capital letter R, with a dilation of 0.5 for triangle ABC. Now, someone tell me, how do we do this? What do we do first? Let's recap. Yep. Yeah. Dilation, then the reflection. Okay. Remember, we go like opposite of reading. We're going from right to left. So that's what they're showing here. They're showing, hey, we have this. It's being dilated by pretty much a half. So it's a reduction. So here's our kind of intermediate points. And then we reflect after that. Okay. So if we look on page 168, and we're going to find the coordinates only. Now, here's the one thing I want you guys to address, because I don't know. Let me check the book. Again, I think this slide is riddled with a few errors. Okay, so in your book it's correct, but this is a small letter R for a rotation, right? All right, so it says the vertices of x, y, z are x 3, 5, y -1, 4, and z 1, 7. What is the graph of the image? We're only going to find the coordinates. We don't need to necessarily graph this. If it asks you to graph after on your test, just make sure you do, okay? So what I'm going to do here is I'm going to create a chart, okay? And I'm going to put in my original points, x of 3, 5, y -1, 4, and z 1, 7. All right, so the first thing I'm going to do is that translation. Who can tell me, what do I do for a translation? What usually happens with that 1 and -2? Shane? Yeah, so the 1 goes with the x values, the -2 goes with the y values. All right, so that's going to leave you with x prime is 4, 3, y prime is 0, 2, and z prime is 2, 5. All right, next we do dilation with a scale factor of 2. What do we do with that? That's from yesterday. Someone tell me. Yeah, multiply by 2. So we're going to have here x double prime is going to be 8, 6. Y double prime is going to be 0, 4. And then z double prime is going to be 4, 10. Okay? Now, for letter B, I want you guys to try that one on your own. All right, so we have a rotation 90 degrees about the origin. Is that clockwise or counterclockwise? It's counterclockwise. Very good. And then we do a dilation with a scale factor of 3. Use the original points, x, y, z. All right, go ahead. I'll give you a few minutes. All right, show of hands. Who's still working on this? All right, I'm just going to go over the answers. If you have questions, please let me know. All right, x double prime, what was it? Shane? Negative 15.9, very good. How about y double prime? So we knew Tony. Very good, negative 12, negative 3. And z double prime. What? Negative 21, 3, very good. Does anybody need to see this? Any questions? Lucy, you good? Yeah. Okay. All right, let's move on. All right, I clear screen. We're going to work on 2 right now. So in this case, it says, is there a composition of transformations that maps triangle XYZ to JKL? So this is the final product. So this is our pre-image. This is our image. Okay. So explain. It says, so first off, these 2 triangles do appear to be similar. All right. And they're definitely positioned differently. So we're going to have here most likely a rotation and then a dilation, right? Question is, how far are we going? Well, with the rotation, if I look at YZ, that's going to have to probably line up with LK, right? And X is going to have to line up with J. So how many degrees are we going to do there, you think? Good. 180. So I'll do a 180 about the origin, and then I'll do a dilation. But we need that scale factor. What's that scale factor going to be? Good. 2. Nice job. So here is what's happening. So there's our rotation, and then there's our dilation. So if we wrote this out, it would look like this. Okay? Now what I want you to do is, I want you on example 2, they want you to use this information. So you should probably write this down somewhere by example 2, like maybe like right under the words try it. The dilation, and that should be a little R, not a big R. I don't know why they keep doing that. But yeah, write that down like right under like try it, like the word try it, because you're gonna use it, but you're gonna flip flop it. But you need like the rule to start with. Okay. So now that you have that, what I want you to do is, if the transformation example 2 are performed in reverse order, are the results the same? Do you think your answer holds for all composition and transformations? Explain. So now that you have the rule, flip-flop it and perform it on these points. These are the points, original points for X, Y, and Z. Okay? And then we're going to check it out in just a minute. All right, show of hands. Who is still working on 2? All right. So with our coordinates, what I'm going to do is I'm going to go back to the other slide. So now the question remains, the coordinates that you have, are they the same as JKL? Yes or no? A big no, what do you think? Yeah, they are. All right, so that answers the first question. Okay, so it says again, are the results the same? In this case, yes. X double prime, Y double prime, and wow, let's jump in today. Z double prime are the same as J, K, and L. Okay, so there's the first part. Now the second part is saying, do you think your answer holds for all composition and transformation? So if we did this to like everything, would this still be true? I don't.
No, we only look for one. It depends on what the other transformation.
Yeah, we can't assume that, right? Because just because we have a rotation and a dilation does not mean that those numbers are going to be the same. Things are going to change. So we're going to just state no. That cannot be assumed to work for every set of points. All right, questions on that? All right, so anybody still writing? Before I move on. All right. We're skipping 3, but leave the space, okay? So let's talk about the habits of mind that's right under example 4. Okay? You guys see that? Communicate precisely. So if 2 figures are congruent, are they also similar? If 2 figures are similar, are they also congruent? So let's analyze the first part. If 2 figures are congruent, are they also similar? What do you guys think? Lucy? Yeah, why? I'm sorry?
Similar in size.
Similar in size. In fact, they're not just similar in size, they're what? They're exactly the same. Can figures that are exactly the same also be similar? Yeah. What's the scale factor? Shane? It's 1. Good job. All right, so that's what you want to write down for the first part. Congruent figures are similar. A dilation can have a scale factor of 1 in this case. This is an always type of thing. Congruent figures are similar always. Okay? Now we're flip-flopping this, right? If 2 figures are similar, are they also congruent? Tony? No? Can they be? Yeah. So just because they're similar does not necessarily make them congruent. So in that case, not all similar figures are congruent. Corresponding sides could have different lengths. Okay? This is a sometimes situation. It's not saying it can't. It's just saying it's not happening all the time. Okay? All right, part 5. We're not going to be doing that write a proof of any 2 squares are similar. That's not happening. What we want to do is we want to focus on circles because circles haven't been widely addressed in the book. So you are going to have to copy down this entire example 5. Okay? Anybody still writing this down, though, before I move on? All right. So again, you're going to need to find space somewhere. There's definitely not enough space by example 5. But if you want to like squish it into 3 and go into 4 maybe, it wouldn't be a bad idea. But you got to write all this down, picture for picture, word for word. Okay? So we're identifying similar circles. So show that any 2 circles are similar. So given circle P with radius R and circle Q with radius S, prove that circle P is similar to circle Q. So part of your proof is translate P to Q, so P prime coincides with Q, then find a scale factor that dilates circle P prime to the circle with radius S. So in your Google form today, you had 2 circles. In order to get that question correct, you needed to look at the radii of each circle. And in that case, they ended up being equal to 1, right? Because they were both the same. The next part of this proof is going to be, so the translation followed by a dilation centered at Q maps circle P to circle Q. Since a similarity transformation exists, then circle P is similar to circle Q. We're hitting proofwriting on Monday. Please make sure you don't write down congruent. It happens, okay? You got to use just the squiggly for similar. Don't write a congruency symbol. It happens a lot. And I'd hate to see you guys do that on a test, okay? Show of hands who's still writing. Okay. Anybody else still writing? Okay. One more minute. If you are done, move down to page 170, perform number 5, please. Emma, are you caught up? Okay. There you go. Bless you. All right. Show of hands, who's still working on 5? Are we ready for the big reveal? Let's see how we did. What questions do you guys have? Okay, homework is actually this half sheet. So if you can get this done before the end of the period, turn it into me, you have nothing to worry about. Realize this isn't like an insane amount of problems. So if you wanted extra practice, I included problems on Realize. You don't have to do those stuff. Okay, it's optional. In fact, it's even labeled as ungraded. So this you will just turn into me. Okay, sound good?